Okay, so the recording has started. If you have any questions during the lecture, please feel free to unmute and ask me or write them in the chat. I'm reading it as we are going. So let's dive into our agenda. We have quite lots of slides to plow through today, so let's be quick about it. First, I would like to tell you about the history of web development. Why do we need to manipulate the document object model, the DOM, in the first place? Next, we will dive deeper into the details of the DOM, how it's organized, how we can manipulate it, what it consists of, how it evolved during the times of web development, how we can access it differently. Also, you will be studying different frameworks. So how can we access the DOM using vanilla JavaScript? How can we do it using jQuery? How can we do it using React, Angular, and so on and so forth? Next, we'll be talking about modifying the DOM structure. And in the second part of the lecture, which will be also today, we will talk about how we can manipulate the DOM using JavaScript with examples. So let us begin. And the first thing I would like to talk about is the document object model itself. Previously in this course, you have studied HTML and JavaScript, but as far as I remember, you have studied them a bit separately. And in order to tie them together to make our websites, our applications interactive so that our HTML is responsive to the user input, for example, I as a user has pressed a button, or I have clicked on a link, or I have scrolled, or I have put any input at all in the system. And to make the system responsive, to make the web application respond to my user's actions, we need the document object model. So it's a representation of a document and its content. At the basis HTML page, if we remember the very, very beginning of the web development, in the beginning, our websites kind of looked like the pages in a book. We had titles, we had text, we just input the address in as a URL, and that was all. Like the pages were not responsive. They were a bit like Wikipedia nowadays, but even Wikipedia is responsive. You can go to other pages, you can search, but very, very first pages, like for example, the CERN website, the very first website that was developed, it was non-responsive at all. You could just open it and view it. And this document structure in the application, it consists of several nodes, and we will study them deeper in this lecture. So it shall be noted that document object model is a standard. So all websites you will come across in the World Wide Web, they are all based on the document object model. So it's universally used. And if we look at the small scheme in the lower right corner of the slide, we can see how everything ties together. So first you have studied HTML, and HTML is non-responsive by design. You just draw with it like a picture. Next, using the document object model, it's a representation of the structure of the document. Using the web APIs, we can dangle it together with user interactions. And also we can combine the styles. So on the right, you can see the CSS, which you have also studied. And when our CSS, when our styles are loaded on the page, they are stored as a CSOM. So DOM is document object model, CSOM is styles object model. And when they are combined together, we get the render tree. And we can communicate with this render tree, which consists both of nodes and their styles, using the ECMAScript or JavaScript, because JavaScript is an implementation of the ECMAScript standard. So, as I told you in the beginning, we had only static HTML pages. And in the very beginning of the web era, it made sense. So you just load the page, you read it, and you close it. A bit later down the line, we could also navigate the site. So you could click the link and go to another site. So this type of page is called static. So you just send a first request, then the server serves you the full HTML page. When you send another request, for example, you click the link, the whole page is being reloaded. Like the server sends you the full page once more. Each new request results in whole page being loaded. If you remember using the internet maybe like 10 years ago, you could remember that if you click a link, the whole monitor goes white and then slowly the page starts loading. That's old server-side loading. So if we look on the right, we could see the URL example. So usually these pages, these documents, they are stored on the server and we have a structure. Like, for example, in File Explorer in Windows. Yes, you have several folders. You have Documents folder, Pictures folder, your User folder, your Games folder, etc. And it's the same. So early in the web development, all pages, all static pages were stored on the server and they were just put in the folders. And the same as you can see in the File Explorer, in URL, you can see that we have like the root, for example, reactjs.org. Then we have a folder called docs, and inside of it, there is a file, a .html file, which you're already familiar with, called React DOM server. And when you navigate to it, you are viewing this file. It shall be noted that React actually behaves differently. It's not a static HTML page, and we will learn how it works actually on reactjs.org site later down the line. So let us look at the next step in this evolution, the server-side scripting. So if your website, if your web application becomes more complicated, if you are getting not 3 pages, but 300 pages, 3,000 pages, it's getting more and more cumbersome to update your site. What, for example, if you want to change the header on all of your pages and you have 3,000 pages and you would need to like go into each separate HTML file and change something. So there are two approaches for this problem. The pages can be pre-generated beforehand with the static site generator. And this means that we generate the whole HTML on the server and then we serve it to the client. And there are various technologies which can be used for that. PHP, .NET, JSP, and even React recently with server components and also with Next.js. And it shall be noted that first, server-side rendering was the only option, like as we discussed before. You're making a request, it's getting sent to the server, you receive the page, you send another request, the whole page gets reloaded, and so on and so forth. But now the server-side scripting, the server-side rendering is getting a huge comeback due to how performance has changed. So let us talk about it. So when we are getting the page, if we are getting the whole page from the server, nowadays with our extremely fast bandwidth internet, it's very simple and easy. If you remember previously, the internet was very slow and getting the page loaded on the server was not a great idea because you had to build everything on the client and it was very, very cumbersome. But nowadays, we have amazing internet and more people are surfing the web using the mobile devices. So server-side scripting is making a huge comeback because you can calculate everything in the huge server rooms. Like, for example, you are serving your application on AWS cloud, everything gets calculated on the server and you receive the HTML page. Obviously, this brings us back to the problem with interactivity. Like if I click something on the page, how it will get reloaded if it's not interactive. It just served me a static HTML page. But there are new technologies developing for that as well. And it shall be noted that many things can also be done even without JavaScript. So if you would like to test, for example, the Amazon.com site, you can actually order from Amazon after disabling JavaScript in your browser settings. So you can do everything just by statically like reloading the pages, and the page will be modified with all of its assets. So it is possible, but with modern applications, it's not always the right approach. So the Wikipedia, which we have already mentioned before, it's lots of static information, like you have loaded the page with some article, for example, about mockingjays, beautiful birds, and you're just reading it. Scrolling, reading it, and you are not interacting with the page. But for example, if you log into Facebook or to Instagram or to Twitter or any other popular social network, there are lots of things happening simultaneously, and the page needs to react to that. For example, you are on Facebook and someone wrote you a message. Message notification counter should go up. Now you have one unread message. Or you are scrolling your page, viewing new messages from your friends. This information should also be loaded again and again and again. And if the whole page was reloading each time, remember, like white screen, everything loads from scratch, it would be a very bad user experience. So, or when we need a lot of interactivity, when our websites, our web applications need to be reactive, we are using lots and lots of JavaScript. And that's why we need to manipulate the document object model to achieve interactivity. So we have moved as a web industry as a whole from static pages, which looked more like pages in the book, static documents, we moved to something that can only be achieved in the web. Like our applications are fully interactive, responsive, and for this, we need to learn today how to manipulate the document object model. How can we do it? So using JavaScript, that's the main purpose why the language was created in the first place. With JavaScript, we can manipulate the DOM. We can replace or reload any parts of the document. So let's see how it is done. So on the first request, we are getting the whole document, but we are not getting only HTML file. As you have learned before, you can connect JavaScript to your HTML document using the script tag. So your HTML inside the body will have the script tag with some JavaScript, and it gets shipped to client from the server together, HTML and JavaScript. And then using JavaScript, you can be making the AJAX request, the asynchronous requests, using JavaScript, and then instead of fully reloading the page, only parts of the page will be updated. So it's a totally new approach. It allows me to change the number of unread messages in Facebook, to change the number of likes on my Instagram posts, or something like that. So without fully reloading the page, we can update the information, and that's the main game changer. So using the document object model, we can change anything on the page. And it may seem an amazing idea, like let's see how the document object model compares to HTML. So on the right at the top, we have the familiar HTML markup. We have HTML tag, head tag, body tag, and inside of this, we have the EM tag, the P tag, and another paragraph. Okay, this looks nice. It's a very, very simple page, but okay, it's understandable. And if we remember the beginning of this lecture, the document object model, it does not create, it is not made from tags. It's made from both HTML and CSS styles and combined together. And the element of which the document object model consists is called the node, the DOM node. The node is HTML and CSS combined, and the nodes, they are in a tree. If we remember the HTML principle, everything has a strict hierarchy. So for example, we have a HTML tag, it's the parent tag. Everything else is inside it. Then inside it, we have the head and the body. In our example, they are on the same level. And inside the body, we have even smaller tags, and inside of them we can have another one and another one. So it's a hierarchy. So it's very easy to illustrate the DOM as a tree. Like we have the main trunk, and then we have the branches, and on that branches we have even smaller branches, and it's very easy to see. But I suppose for better visibility, we could turn this tree upside down. Like this is the HTML tag, and from there we are having the header, we are having the body, and from there we are going lower, lower, and lower, and the branches are getting smaller and smaller. Okay, everything looks good so far. And remember earlier we looked at the reactjs.org website. Here's the part of its document object model. It's already a bit hard to see, but I will read it aloud to you. So first we have the header. Inside the header, we are having two divs. I'm going from left to right. Inside the divs, we have navigations, we have forms. Inside of them, we also have in navigation several links to go to other parts of the site. Inside of our form, we have spans, inputs, buttons, and so on and so forth. Okay, so far still understandable and a bit easy to traverse, but it was only the small part. So the rectangle, the light blue rectangle, is the part that I have demonstrated to you on the previous slide. And the whole page, it's a really big DOM tree. So it's not easy to read and it's not easy to traverse. So the more complex your site is, like the more complex HTML you have, the document object model hierarchy, its tree, it will also be getting more and more complicated. And for you to target specifically the node you want, to get it with JavaScript, to change something, it's getting more and more cumbersome. And what if you want to change several nodes at the time? What if you want to add something, delete something, change the styles on this DOM node? For example, I have clicked a link and now it's not blue, it's orange, for example, due to the design. And that's where jQuery comes in. jQuery nowadays it's mostly thought of something deprecated, not widely used, but that's actually not true. jQuery is still good and true, and it's actively developing, and they recently received the major 4th version. So there are lots and lots and lots of amazing things that you can do with jQuery. And today, a bit later down the line, we will discuss why it came out of fashion, what was the real reason. But let's see what jQuery is. So when we are developing our web application, it shall be noted the document object model is the standard, but we have several browsers. Like if we look at the landscape today, we have like Chrome browser, Firefox, Safari, Explorer Edge, and also even the Internet Explorer, the oldest one. It's still widely used, especially in the government sector. And if you want your application to be profitable, you would like for it to be running properly on all of these browsers. There shall not be a situation where I try to order something from Amazon, for example, and I open it from Safari and I can't do anything on the site because it's working only for Chrome. Like that's not acceptable from the business point of view. But sadly, browsers are very different, and especially all the browsers, because browsers are also like applications. They are receiving regular releases, they're updating, they're getting new features, but they're also old browsers. For example, like Internet Explorer, which was being stopped, actively developed like several years ago, but it's still being used by government organizations. And in lots of countries, we are required by law that the information is accessible to everyone. And if you open this website from even the very, very, very unupdated browser, it is still working. And this issue is called compatibility issue. I need to write my web application in such a way that it correctly opens from Safari, Internet Explorer, from Chrome, from lots and lots and lots of browsers. And to prevent compatibility issues, jQuery was developed. So instead of using the DOM API, jQuery is like an abstraction above it. Using jQuery, you are able to manipulate DOM, but using other methods, using a layer of abstraction, which allows jQuery under the hood handle it a bit differently for different browsers. And thus you can achieve compatibility, like you're doing one thing, and you can be sure that using jQuery, this will be done correctly. And even more importantly, it will be totally the same in many different browsers. So jQuery is still widely used. You will not encounter jQuery, I suppose, on the new projects which have been started recently, but in so-called legacy projects, jQuery is still used a lot, and you shall not be afraid of it. It actually has amazing, easily understandable syntax, lots of good documentation. It's just that now we have something new which makes jQuery deprecated, and that magical thing is single page applications. So what is single page application, or as it's widely called, SPA? In the first part of our lecture, we discussed that server-side rendering, it's multiple page application, it's static page generation. You are sending a request, you are getting a full document back. You are sending another request, the page reloads, you are still getting the whole page back. Using JavaScript, we can bundle together what you are getting. You're getting not only HTML, but HTML bundled with JavaScript, because we have inserted the script tag in our HTML document. And now your page can be a bit interactive, but still, if you go to another page, if you click the link, for example, to another slash in the URL, the whole page will be reloaded. But this is not very nice for interactive applications. For example, Facebook that we have discussed earlier. So what is a single page application? How it is fundamentally different? So modern SPAs and both Angular and React and also Vue, they promise us a scalable and simple solution. So the architecture is totally different from statically generated server-side rendered applications. What we are doing with SPAs, we are sending one request, the first request, to the server. And then we get the HTML file, and then we get the JavaScript bundle, and all the markup will be assembled on the client with JavaScript. We are not being served the page as a whole. So we are just being served the skeleton, and all of the work shall be done on the client. So it will be done in your browser or in your web application if you are downloading it from Google Store or Apple Store or something like that. And it allows us to build everything on the client and to send lots and lots of requests to receive new data, like, for example, the number of likes, the new photos, the new comments, the new posts on Twitter, etc., and then partially update the page without fully reloading it. So everything is built in the browser. That's the key difference between multiple page application, which are rendered on the server, and single page applications, which are rendered in the browser on the client side. So why did this make jQuery deprecated? They're just completely different. Instead of manipulating the DOM object model, the document object model, we are splitting our applications in a different way. So now we are not reloading the whole page. I received a new comment and I would like to update only the small part of the interface, for example, the comment counter, but I want everything else on the page remain the same, to not reload it, to not update it. So I would like to also update this like counter in several parts of my application so that everything is in sync. Otherwise, it will be a huge issue that in this part of the website, the like count is 3, here it's still 2, there it already received another update and now it's 4, so I need my data to be synchronized. So instead of splitting our applications in pages, as we discussed earlier on the server, we have several folders. Inside of the folders, we have HTML files, and that's what you're seeing in the URL in the browser. Here, we are using the component-based approach. So we are building our applications using different building blocks. What is a component? Component is HTML, JavaScript, and CSS. So styles, it's HTML carcass that we will be seeing, and also JavaScript logic. It's all bundled together in one neat, tiny piece. You can think of it as a Lego piece. And it's handling itself. Like this component can itself send the request to the server, receive the data, update, and other components will not be touched by this. And that's how I can update only my likes count, for example. Other page stays the same, other parts of the page, and only my small like count, the like count component, is updated. And this means that we are getting another layer of abstraction. Instead of working with DOM methods directly, I have component now, which bundles everything together. And now there is a special approach that is called declarative. There are two ways in which we can write our code, imperative or declarative. So when we are writing our code in imperative style, we are writing an instruction for the computer, what it shall do. If we are manipulating the DOM directly using its DOM methods, it will be imperative. It will look something like grab this element from the DOM, like an instruction, from this element, add this element to it using this method, then get these styles, update them on this element, and so on and so forth. So we are writing an instruction. We are telling the program how to do things, step-by-step instructions. But with the new SPA component-based approach, we have this new abstraction layer, the component. And we do not want to be writing the instructions using the DOM methods. Instead, we are using the syntax which is provided to us by React, by Angular, by Vue. We are using this layer of abstraction. And then you will be studying React in the next step of your education. You will see that you are updating component using specific React syntax. For example, use state, specific function which you get access to when you install React, or for example, use effect. So this is a specific higher abstraction layer. You are just telling what you want to achieve. What do I want? I want to update my like count component. I want to get new data. I want it to be displayed. I do not care how it will be done. I'm not getting into the nitty-gritty details. I'm not working with them directly. Instead, for example, I'm using React and I'm just calling the use effect function, which will fire the side effect and update the component. Under the hood, of course, we will still be manipulating the DOM. It's how things are getting done. It's just that we'll not be doing this ourselves. We are writing a higher level abstraction, and then under the hood, React as a technology, as a dependency we are using in our project, allows us to update everything. So in order for everything to be working, we will need strict borders between our components so that when our like count component is getting updated, other components are not affected by it. We need to separate our components. If you look at HTML page, everything is bundled together. Yes, like it's one file. HTML document is one file, and in old world, it was one HTML page. One HTML file equals to one page. But now, instead of one page, we have different components, and they are making different requests to the server, and they're updating using Ajax. So we are not serving the document from the server. We're doing all calculations on the client, and just the data is traversing between client and the server. So obviously, there lies a huge problem because we would need to learn the approach, how to split the page into different components, because depending on the business logic, on your mockups, on the business goals of this application, you would need to split this page differently. So there is no universal approach. You would need to understand how to split the page into components, and you will be learning this when you will be studying React. So why do we need to study document object model then, if we will be operating in modern web development, not with document object model methods themselves, but with higher level abstractions provided to us by the frameworks we are using, the React, the Angular, the Vue, and so on and so forth. It shall be noted that it is still being done using DOM. So if you understand what is happening under the hood, it gives you a much better visibility. It gives you a much deeper understanding on how things are working in your applications, and it allows you to debug it much more efficiently. And also, sometimes in specific cases, you would still need to manipulate the DOM directly, bypassing this higher level of abstraction. All these frameworks, React, Angular, they are giving us methods and ways to bypass this abstraction layer and still manipulate the DOM directly. But these methods shall be used with caution. For example, in React, there is a specific thing called ref. Ref is from reference, so it's a reference to the DOM node of your component. So as we have learned today, component is a higher level abstraction, which bundles together HTML, CSS, JavaScript. It's like an abstract layer with which you are interacting when you are writing code using these frameworks. But under the hood, it still consists of HTML, CSS, and JavaScript. And in the end, it will still be rendered in the document object model as some HTML nodes, and it will appear in the document object model as a node. So it will still be there. It's just that component provides you with a higher level abstraction, allowing you to write code in a better way, in a faster way. But in the end, it will still be rendered as HTML with CSS styles on it. So sometimes you may need to manipulate this node directly, this HTML tags of your component. And you can do this using reference to it. In React, this is called ref. But this is not the preferred way of doing things. So when you will be writing your web applications using React, Angular, Vue, other frameworks, they provide you lots of methods like useEffect, useState, etc. These high abstraction methods, which allow you to manipulate the DOM. And only in exceptional cases, like if everything else failed, if there is no way to achieve what you want using the methods that your framework provides to you, only then you shall be using refs. Because there is nothing worse than React application which is written not in declarative, what I want, but in imperative, how to do things way. If you are using lots of refs, if you're manipulating the DOM directly, it really messes up the React applications in terms of its performance, of how things are done, and how its state is changing, how it's requesting data. So the imperative approach shall be used in exceptional cases. If nothing else can be done, it shall be like the last resort. And just to return quickly to jQuery, as I've told you earlier, yes, we are still using that. jQuery is not for SPAs. It's not for applications which are written using modern frameworks, because in React, in Angular, in Vue, in other frameworks, we have their own abstraction methods. We do not need jQuery for that, because these applications, they shall be using declarative approach, not modifying DOM directly, but working on a higher level abstraction level. But of course, there are lots and lots and lots applications on the World Wide Web which are written before React or Angular or Vue were created. And these are still multiple page applications, and jQuery is still widely used with them, and even with AngularJS. Maybe you know AngularJS and Angular, they are totally different frameworks, even though the name sounds really similar. So AngularJS is the first version, but then Google, the developer of AngularJS, they changed their strategy dramatically, like what is AngularJS, how it shall be used, what are its principles. And the change was so dramatic that a totally new framework was created, Angular. So these two, AngularJS and Angular, are very, very different. And if you encounter in your future work an application which is written using AngularJS, it is bundled with jQuery. It's such an old framework that it's not using the component approach yet. It's like, it's as old as Backbone, almost. It's very old. So if you will arrive at the legacy project, you will be using AngularJS together with jQuery. So we shall not be afraid of it. Like jQuery is still good, it's still nice, it's just serving a different purpose. It's not nice, it's not feasible to be using jQuery with SPAs. So let us go into the second part of our lecture, the document object model. As we have discussed, the document object model is a tree. So when the web page is loaded in your browser using HTML, using the hierarchy on the nodes, because we have opening text and closing text, like HTML tag, inside of it the body tag, then the head tag, inside of it, for example, a title, and etc. Using this HTML, we are creating the document object model, the tree. So, and every node is an object, and the document object model can represent not only HTML, but also XML documents. So as we have seen, the HTML page on the left is represented in the DOM as this tree-like hierarchy. DOM consists of the several elements. So let's see. There are different types of nodes, and we can return different types of collections by calling the methods. So here we have a small example. We have the document, and we have these three tags inside of it, like EM, P, and another paragraph. So, for example, how can you manipulate the DOM in the browser? How can you try this out after this lecture if you're curious how to do it? So this screenshot is taken from the browser after opening the developer tools. So you can hit Shift-Control-C or, for example, F12, and the developer tools panel with console can appear. And because JavaScript is entirely integrated with the browser engines, for example, Chrome runs on V8 and so on and so forth, you can totally write JavaScript in the browser. I'm totally sure that you have already done it when you were studying JavaScript in previous lectures. So in the browser, we can access the document by writing document dot, and then as you have studied in JavaScript, because of how inheritance works, we can get access to lots of methods which are specified on the document prototype. So you can call, for example, document to string, and this will stringify the entire document object model. So it's an object, and you can stringify this object, and you will get all your HTML represented as a string. Also, you can get different elements on the DOM. So, for example, if I want to get all elements with the tag EM, what can I do? As we can see in the code, let EM nodes equals to document dot, we are calling a method, get elements by tag name, and here we are passing the one and only argument EM as a string. And this will return to us an array because there can be several elements with the same tag name, even there will always be an array. So even if your document object model, there is only one element with EM tag, it will still be an array just with one item. So there is always an array of items. And you can also stringify these nodes as well. And we can also, because it's an array, we can take its length. For example, emnodes.length will give us 2, because in the example above, we can see that there are 2 em tags, one with class elf and another with class Maya. And you can also stringify them individually. So this is a quick example on how we can be accessing different nodes in the document object model. For example, we can get them by tags. So what are different node types? The first, the main one, the parent one, is the document tag, the one on which we were calling all these methods. Next, there are elements. They can be text, comments. On them, there can be attributes. For example, on image tag, you can have the src attribute, the alt attribute, the alternative text to be displayed if image is not loaded. So all elements can have their attributes. And even deeper under the hood, you can have the shadow roots, the CData sections, processing instructions, and document fragments. But usually we are not using them. They're a bit deeper under the hood. Usually you will be using the ones highlighted in blue, the documents, the elements, the text content of the elements. For example, if we have our P tag, the paragraph, and inside we have like hello world, we can get only the text hello world using text type and also using attributes. So if we look at this tree, we can see the object hierarchy. So on the first level, we have the HTML elements, which are stored like inside the HTML document. Next, we have the document object model itself with all the nodes, different types of nodes that we have discussed previously. And they are also under the hood, they are a JavaScript object. So here we can see an example also in the console, how we can be using different methods. So for example, we can get using the method object keys all methods that are stored on the document prototype. Like JavaScript uses prototype inheritance, so we can see that there are lots and lots and lots of methods that we can be using. Next, lots and lots of methods that we can be using for HTML elements, like its attributes, its methods, so on and so forth. Next, for element, and finally for the node. I suppose this looks a bit like gibberish and it's really lots of methods, but the good news is that you do not need to learn them by heart or anything. As I told you before, usually in modern web development, we are not traversing the DOM imperatively using these DOM methods. It may be nice to know that there are lots of DOM methods, and if you encounter a task at your project which requires you to pull off your imperative sleeve and then use something that is not React or Angular related, then you can search up the documentation and see which method can be applied. But I would not advise like learning everything on this page by heart. It's not needed. You should just be aware that there are lots of attributes and methods for manipulation on the DOM tree. And that's the main takeaway. So there is no need to learn anything. I suppose several things that you shall be learning are the user event inputs, like for example, how to catch when user clicks a button, how to catch when user clicks a mouse, left mouse button, right mouse button. But we will study this as well in this lecture separately so that we don't have to look at this scary slide. So the next topic is how can we access the DOM? There are several ways. In the previous example, we have studied that we can get all elements by their tag, but we can also be getting elements in separate ways. For example, we can access the element by ID, get element by ID method, and it returns the first element. So instead of array of elements, you will get only one element. So the result of running this method will be the element itself. Next, the method we have already learned, get elements by tag name. There we will be returning not one element, but a collection, an HTML collection of all elements which have the same tag. For example, you can run document, get elements by tag name, Lee, and it will return you all items of the list. It should also be noted that we can be running these methods not only on the document, but also on the structures we have studied previously, on elements, on HTML elements, and so on and so forth. Also, when we are using CSS, we are attaching the CSS class names to HTML. Yes, so we have our separate like CSS, SCSS, SAS file with the styles, but still we need to indicate that this HTML DOM is using this class. For example, my cute class, and now the text underline will be red. So we can get all elements in the document object model which are using the same class. So get elements by class name, my cute class name, will give you all the elements which are using the CSS class. We can also get elements by their name. It will return us a node list of element in the document that have a name attribute with the value name. And also query selector and query selector all, they are very versatile methods, and you can specify a selector. So in previous methods, they are accepting only one parameter, like get element by ID, accept ID, get elements by tag name, you are inputting a tag, get element by class name, class by name, inputting a name. But query selector and query selector all, they allow you to write custom queries. Like for example, for my purposes, the methods before them are not enough. I don't want by class, by name, for example, I want to get my element in the document object model by some custom attribute. For example, in my testing strategy, I have an custom attribute on my element called test ID equals 1, for example. So I want to get an element by test ID with its value 1. Previous methods, they are not enough for that, so I can use query selector, write a custom query, and get element by any selector I want with any value of I want. And the difference between query selector and query selector all, query selector returns you only the first element. It's very similar with the array find method. The find method will return you the first element. And query selector all is more similar like a filter method. It will return you all node elements which respond to the parameters you input. For example, all elements which have the test ID which equals 1, not only the first one. So let's
Sorry, I have a question. If query selector can do own thing the other method can do, why we don't just use that?
It has a bit more complicated syntax. For example, if I want to get an element by ID, it's much simpler to just get element by ID, pass an ID, and everything is nice. But if I'm writing a query selector, then I will need to pass manually that I'm searching by ID parameter, then I need to input that I'm searching by value of this ID parameter, and so on and so forth. So yes, totally. We can do everything by query selectors. But we still have these methods, and they are also a bit quicker in the performance side, because get element by ID, it's searching strictly only by IDs. So it's a bit more performant, it's quicker than using query selector. So if these 5 methods are not applying to your case, like it's not by ID, not by tag name, not by class, not by name, then obviously you can fall back to query selector and search by anything and everything you desire. So mostly it's simpler syntax and performance.
Okay, I understand that.
Okay, glad I was able to answer your question. Let's move forward. So next, let us talk about the accesses on the subtree. So let's see an example usage of the methods we have just discussed on the previous slide. For example, we can use these methods on the document itself, like the whole document object model can be accessed using the document. So document get elements by tag name P will return us not one element, but the collection of all elements which are using the P tag. Okay. Also, I can get elements by tag name, div, and then I can chain the methods. Yes, it's JavaScript, and remember that we can chain the methods. So I can get elements by tag name div, then I can get as HTML collection, it has access to the same methods as JavaScript array. So I can totally get the first element by its index. So here I'm doing document, get elements by tag name div. Then I'm getting the first element in this collection by using index 0. And then inside of this element, I'm getting elements by tag name p. So I can do it like that. And also, if I'm doing it get element by ID, then I will get an error. So there is a difference between an element node and also getting element by ID. So getting element by ID is not used on inside functions and can be only used on a document. Because if we remember, ID is a unique identifier. Like it's considered a very bad practice to have several elements which have the same ID. Like it's used to target specifically one node on the document object model. So you shall not be using like document P ID1, next P is also ID1, and so on and so forth. If you need to select several P tags, then they can have the same class on them, or you can be using select by tag, or you can add a custom element, for example, test ID on them and select them customly using the search query. But get element by ID cannot be used on an element node. It can only be used on document get element by ID, because we assume that there is only one element with such an ID inside the whole document object model. Also, we can be accessing the elements by ID, tag, class, and name, the methods we have discussed earlier. So here the examples. First, we are searching the element by ID question, and because we are calling this method on the document itself, on the parent node, it's working correctly. Also, here can we get elements by tag name, by class name elf, and for example, get elements by name Legolas. And just to make it clearer for you, so here is the HTML, and here's how we can be getting these elements. Also, we can be accessing the elements in document object model by CSS selectors, because as we remember, we write our styles in a separate file, but then we still need to indicate that, for example, this EM is using class elf and name Legolas. And by attribute name, we can search using name attribute. That's why we returned em.elf running this search query. So when we are using query selector, we can see that the syntax is a bit different. So first we need to show when, where we are searching and what we are searching. We can learn more about it on MDN. I can provide links after lecture because query selector is a very useful tool. It's very customizable, as we've discussed. So it might be nice to learn its syntax. Well, we have grabbed our element in the document object model, and I suppose the next logical step will be to do something with it, because we do not want only to access it, we want to actually change it. That's the whole purpose of document object tree, interacting with our HTML document. How it is done? Here, for example, we are getting element by ID question, and then I want to change the inner text. I do not want to change the tag it's using. I don't want to change the attributes. I want to change the text context which is inside it, inside the tags. So I'm just saying question, inner text, and then I can modify it. I can not only like replace it, I can update it. So here I'm using the previous text, question inner text equals question inner text, the previous version of it, plus, we know this syntax, in JavaScript, we can concatenate two strings. And so using plus, instead of sum operation, these are not numbers, I will actually concatenate the strings. I will put them together. And so I'm just writing plus set Legolas. And now we can see that instead of there not to see the merry young hobbits again, we have an addition, set Legolas. And it also appears on the document. So if we ask the console to output us the whole document, as we have done, like type document, and you will receive the whole document object model. Now we can see that everything is updated. So this is how you can imperatively change or modify text content on the element. Also, we shall learn the difference between inner text and text content. They are significantly different. So text content gets the content of all elements. So it can even be used on script, on style, but inner text only shows like the actual text that the user is seeing in the browser. So text content returns every element in the node. But inner text is a way of styling. So if you have, for example, styling display hidden, so the element is not present to the user. If I style something with display hidden, I will not see this as a user on my monitor when I'm viewing this web application. Then the text content will find nothing because it's not visible. And also, since inner text takes styles into account, reading the value of inner text triggers a reflow to ensure that the styles are updated. So when you're using inner text, it's less performant than using text content because we assume that using the inner text can modify the styles, so we are recalculating them because we cannot guarantee that using inner text you did not modify the styles. If you want your actions to be more performant, to be quicker, to require less resources on the client, then you can use the inner text. So here we can see the comparison. So here's our question, and its text content is, then are we not to say the merry young hobbits again, said Legolas. And then if we query the document body inner text, then we will see this paragraph. But if we go to text content, then we will see all elements on the node. Next, attributes. As we are already aware, after studying HTML, we can set elements on the attributes. And manipulating the document object model, it allows us not only to view them, but to actively change styles, like you can change styles on the fly. So, for example, I want to change the style and the color of the text of the phrase where we're not to see the merry young hobbits again. Amazing phrase, I love Lord of the Rings. So let's see how we can do it. First, we need to get our element from the document object model. So let question equals document get element by ID question. Okay, now we got it. Using this question, we can call methods on it because it's inherited from the document, so it has access to all these methods. Question dot get attribute ID. We are getting its ID, its question. That's how we were able to get it. Also, it has attribute style. Right now, it does not have it. So attribute style is where all the CSS styles are being stored in the document object model. Right now, this element does not have any styles. So let's set them. Question, set attribute. The first argument will be style, and inside of it, there will be the all different styles that we are adding. So by using style, we can not only add like CSS classes, we can actively add CSS itself. For example, here I'm adding color blue, which will color the text blue. And also, for example, I can remove another attribute, for example, ID. And then after we input this question, we can see that it's a paragraph with style color blue, but there is no ID on it. Also, I suppose we shall learn about the difference between the attributes and properties. So, some standard attributes are mirrored as a property on the object, for example, ID, class, style, etc. However, their mappings are not trivial. Class becomes class name, style properties become camel case. So setting them as a node property will also affect the attributes. Let's look at the example. Here we have a small HTML fragment, there is a body, they're already familiar to us, EM tags and two P tags. So first, let's get an element from document object tree, access it. So let answer equals to document.body.query selector. And here we are writing our custom query. We can see that syntax is a bit more complicated than, for example, just running get element by ID. But what we are doing, so we are getting the EM tag, which has class Maya and name Gandalf. And also we want to get paragraph with ID answer. So we have been able to select like several of them. And that's actually awesome. So answer has attribute style, it's false. But also, if we try to get answer.style using different syntax, we can see that there are some styles. So even though we don't have style attributes right now in the documents, if we look at answer.style, then we can see all the possible properties that can be applied. Like, for example, align content, align item, they're listed alphabetically. That's why they're all on A. Okay, then we can use some of these methods. So instead of just asking if there's an attribute style, no, there are no styles added right now, but we can be using style methods. So answer dot style align content. And if we align content to start, and then we print answer to the console, we can see that it has changed. Now we have applied it. And also we can do it differently. For example, answer set attribute, style, the syntax we are already familiar with from the previous slide. So set attribute style and then align content center. And then it's centered. Then class list. Lots and lots of times there will be more than one CSS style on your element. And it can be very inconvenient trying to cherry pick all the styles. So class list provides a convenient way to modify several classes on the element. So class list is amazing, but for example, it's not supported by all the browsers. There is an amazing website called caniuse.com, and there you can check the availability of methods in different browsers. For example, Internet Explorer likes to give us some grief because it is very old and it's not supporting lots of things. But if in your future projects you will have to support the Internet Explorer browser as well, for example, as I do on my current project, because we are working for the library system and it's being very actively used in many government institutions in USA and also in Germany and so on. So if you do need to use class list, but you have to support Internet Explorer, there are some awesome things which are called polyfills. So if I do not have access to class list on the Internet Explorer, I can just add a dependency to my project. And I can add some code which will manually add this function, like I can write it myself. Or I can use for example, Node Package Manager, NPM, and add this polyfill as a dependency. And in your professional time, you will find lots and lots and lots of polyfills for Internet Explorer, letting it access many amazing things that have been developed after its support has been stopped. So let's see how we can manipulate using class list. For example, let Gandalf equals document query selector, and here we are passing the em tag with Maya class. Okay, and if we look at class list, we can see that yes, indeed, it's Maya with Maya. We can also, for example, add another class, wizard. We can remove the Maya class, and then if we view it, we can see that there is no Maya class. Instead, we have wizard. Then we can replace the class. Then we can also toggle something. For example, with CSS classes, we have attributes. For example, hidden attribute. Yes, it can be false or true, whether we are displaying the element in the browser on the client side or not. We can also just toggle it, and because it's a Boolean value, it's toggled between false and true. We can just toggle it, and then hidden will become true. And then if we list our class list, we can see that we have Maya, because we have changed it again from wizard. And then we also have hidden, and the whole values will be value hidden. So the class list is amazing for doing manipulations so when your node has several styles. But it shall be noted that it's not supported with everything. Okay, next, let's talk about modifying the DOM structure. So far, we have only taken the elements which are already present on the DOM tree and changed their attributes, changed their name, changed their inner text, so on and so forth. But actually, we can do so much more. We can modify the DOM structure itself. We can add elements, we can delete elements, and so on. So in HTML, with in HTML, we can insert text as parsed HTML in the DOM. But it shall be noted that when you are using in HTML, you are adding not only text, it can also be used maliciously. So for example, with in HTML, you can be inserting links, you can be inserting script tags, you can manipulate the site in such a way that was not intended. For example, what if on your website you have a form and the input is not sanitized? Sanitizing is when you are preventing anything but plain text to be input in your forms, and it's considered good practice. For example, maybe you've heard there has been a memo released. It's released by Amazon Game Studios and it's called New World. So as a massive multiplayer online game, obviously it has a chat where players can talk to each other. And for some reason, the developers did not sanitize their chat input. So players who were web developers but had bad intentions, but had the knowledge necessary to do bad things, they began using this chat to not only type like, hi, who is there on the server, but to input links there, to input images there. And they were able to, for example, break the experience for all other people on the server, because instead of just receiving a small message in the chat, what if I put an extremely large yellow circle, like the full HTML fragment with styles, with everything, and make it so big that it covers the screen? And if you remember, the chat in multiplayer game is displayed to everyone, for example, if you are writing in general. So by not sanitizing the input, developers were faced with a difficult situation that people who had malicious intentions were able to break the gaming experience for lots and lots of people by using the general chat in an unintended way. So always sanitize your inputs. It's good practice. And here we can see an example of such manipulation, even though it's not malicious in this case, it's just a small example. So what are we doing? Here we have the question node, which we are already familiar with. So question in HTML equals span, and then inside we would like to add question in a tag. So we want to add a span tag here. Okay. It works. Now if we get document get element by ID question, we can see that inside our paragraph, there is also a span. So we have changed it. Previously, we had this text written inside paragraph tag, inside p tag. But now we were freely able to change in HTML to include entirely another node, span, and inside of it the text that we desire. But we can do worse things. For example, question in HTML equals image. Image with some source, and if image is not being able to load, for example, there is no SRC Bilbo says on this website. And here we have loophole. So if you, for some reason, want to do something malicious on your site, please do not do this. I'm just teaching you so that you can protect your own web applications from such malicious things. So let's see what is happening there. Question in HTML equals, we are attempting to add an image, but we are providing an errors SRC. So there is no way we can load such image. And then we are adding on error. So if you do not load this image, do something on error. That's standard browser behavior, sadly. So on error, for example, we can display an alert with something. And here it is. It worked, and we can see on the screenshot that we were able to display an alert by running in HTML and by adding their on error handler. So in HTML, even though it does not run script elements by default, so if I try to write script, for example, on this example, we have question in HTML on the third line equals tag script, and there we have alert. This will not work. But as we have discovered on the previous slide, if I do this trick with image and on error handler, sadly, it will work. So please be very careful with inner HTML and always sanitize your inputs because lots of bad things can happen with that. Okay, let's talk.
I'm sorry.
Yes.
I still get how inner can harmful because inner HTML wizard input is from the local and it will affect the local. Why is harmful our website?
There are differences on what we can do. For example, if I go to react.org com website, I can obviously use, like, for example, inner HTML and break the site, but I will only break it for me, like on my client. And what I am doing with inner HTML, like displaying some alert windows with Bilba saying something, it will only be affecting me, my client. Nothing is being sent on the server. And that's the main thing. Like react.org website does not care if one of its users, me in such a case, is breaking something on my client. If I reload the page, the information will be loaded from the server again and all my changes will go away. But if you are not sanitizing a form input, for example, when you are hitting send on the form, this information is being sent to the server. And if the input is not being sanitized, some malicious hacker, for example, can add a script which will do something on your server. So you can transfer this information from your client, the script or something to the service. And there it becomes a problem. And that's how, for example, the set example with New World MMO worked. Because when I'm writing in chat in MMO, I'm not only doing it on my client, I want to communicate with other people. So obviously my message gets to server and then it is sent to clients of all the people present on the server. And with this yellow image, people were able to send this big yellow square to the server, and then this yellow square was being sent back from the server to all the clients of all the people who were present. And instead of the chat, instead of their like screen interface, their character, anything, they were just getting this yellow big circle, square that was breaking their gaming experience. So as long as all manipulations stay on the client side, if I'm not a developer, I'm a user, I have bad intentions, for example, as long as it affects only me, well, I can break anything. It will not affect anybody. But if your inputs are not sanitized and this malicious script can get to the server and affect other people, then it becomes a real problem. So please sanitize your inputs.
Oh, I don't know about the word sanitize, how you spell it.
One moment. Sanitize inputs. Here, I wrote it in the chat, and you can search for different examples on it. Usually it prevents anything other than plain text to be sent. So there are lots of software which is doing this. So on most of web applications, you can just add some npm package which will be checking, like why are there some strange things in the text. For example, if it sees something like this, like why inside the input we have like this special symbol and the name of the tag, maybe it's some malicious thing, and then it will not be sent. So sanitizing inputs and not allowing any scripts or something like that to be sent, because you can try to send, like, for example, a string, but inside of it there will be like scripts and something else. And so there is lots of software on the market, which and also free software available to everyone, which allows us to prevent any bad things happening on the server from the user input, because it's like a widely accepted issue. Okay. I will
Okay, I
write.
understand now.
Okay, that's Amazing to hear, and I will also give me a moment, write this down and provide an example after the lecture. To give you an example of sanitizing. Okay, let's go further. Let's look at how we can be creating new elements in our document object model. So here, for example, we have our already very much familiar 2EM and 2P tags in document body. And for example, I want to create a new one. So I'm writing let bilbo equals document create element. And I'm passing the type of tag I want to add. Okay. And then if I look at document body get elements by tag name EM, remember that it will get us all the elements, but it's not there yet. We have created it, but it's not there. What happened? We need to append this element to the document object model. So let's first add something nice to our Bilbo element. We are adding a class name, we are setting an attribute name with value Bilbo, and we are also adding inner text, like the safer method. Inner text, which can only manipulate the text that user can see, and not like in HTML that we discussed previously. So good morning, said Bilbo, and he meant it. And then we are actually adding this element. So the main takeaway is when we are creating elements, first we create it, document create element, and then second step, we are adding it to the document object model. So document, body, append, child, Bilbo, what we are doing, we are appending this element as a child inside the body tag. And now if we display the document body, we can see that inside the body we have everything we had before, EM, P, and then we have our new EM. So if you are just writing document body append child without any other arguments, like where to append it exactly, what to do, it will be appended, added to the document object model as the last element, as we can see in this example. Okay, a bit more complex example. So let's, for example, create a text node. So we are creating it on the document. We are calling this method and creating a text. The sun was shining and the grass was very green. Okay, then because this is an object, we can stringify it. Then we can look at Bilbo example from before. So now Bilbo is an EM node with class Hobbit named Bilbo and the text that we described on the previous slide. And for example, we want to insert something not after Bilbo, but before it, like a more custom example. So we can use a specific method, Bilbo, insert before, like insert before the Bilbo node. And we are telling us that we want to insert what? Narrator, first argument, and how we want to insert it. As a first child of Bilbo. So we want to add it in the beginning of Bilbo. And now if we display it, we can see that we have EM with class Hobbit and name Bilbo. Nothing changed. We did not overwrite anything. But inside the text node was added before the old text. So previously we had good morning said Bilbo and he meant it. And by using these methods, insert before and insert as a first child, this text was added before the old text. And if we look at child nodes, we can see that there are two nodes in this list. They are both text. So as a user, I do not see the difference. But inside, it's not one text, it's two text nodes. So if we decide to remove this element, then we can insert it again. So that's how we are manipulating that. And obviously you can insert it as a last child, you can insert before, you can insert after. There are lots and lots of methods which allow you to be extremely precise in how you are adding or deleting elements from the document object model. Okay, now we are getting to the best part. How we can make our applications interactive using JavaScript. Because before we are mostly studying the static things, like for example, how to add HTML node, how to change its class, how to add text, how to delete text. But how can I be reactive? How can I add this node when user presses a button? And that's what we will be studying in this part of the lecture. So we still have like 30 minutes to go. And in these 30 minutes, we will together learn what are events, what is events propagation, and what is event delegation. And this will give you all the tools needed to get started with listening user events and manipulating the document object model based on these events. So what are events and why do we even need them? So as we have discussed in the very beginning of this lecture, at the very beginning of the web development, the pages were mostly static. And we did not listen for anything. You just input the address in the URL of your browser, and then you just receive the result. But nowadays, we want to listen for user events. For example, I clicked on something in the Instagram. I put a like. So the browser or the web application needs to know that, this user on their client, they clicked a button and they clicked their mouse specifically on this element, on this like button. So we need to listen for the event of me clicking in order to send this information to the server and then update it. So for example, my friend whose post I have liked will receive the notification that I liked it, and also all other people who are currently scrolling their thread, they can now see the updated like count. Previously it was, for example, 2 likes, now it's 3 likes, including mine. So we need a start point, like we need to listen for user input in order to then fire all the logic that we want and that we need, how we are reacting to the user input, hence the reactive applications. So here's a standard program flow. So like first the program starts, for example, our application renders, then there is some user input, and based on what this input is, we are making some decisions, and then we are outputting something. But in the world of the modern web development, our scheme looks a bit different. Let's see how a more specific, a more close to real life application scheme looks like. So first, our application starts up. For example, I go to this react.org website, which I suppose I mentioned way too frequently during this lecture. Okay, let me go to google.com site. So the initial code is being fired, the HTML is being shipped to my client, and I see this familiar search window of Google. When the program is starting, we are reading my configuration. For example, if I am logged in as a Google user, which language is being set up? Like, shall we display the Google search for me in Russian, in English, in Korean, etc., etc. And after we have read configuration, we are also looking up the user data. For example, what I have searched previously, what were my last searches, how can we update my history, what were my preferences, like what color scheme shall the Google search be using, etc., etc., etc. Also the geolocation, from where I'm using Google search, so that the search results can be filtered appropriately. Like, am I searching from Moscow and asking for restaurants, or am I searching, for example, from Tokyo and searching for restaurants? Like, it will be more logical to show me the Moscow restaurants in Moscow and Tokyo restaurants in Tokyo if I did not input explicitly Tokyo restaurants while searching from Moscow. So lots and lots of things are being loaded on the first go, and application is ready for work. So based on all of this information, we are building the UI. We have built the UI, and now the application has stopped. Or I suppose the better phrase will be the application is waiting. It's waiting for my input. So as long as I'm just like staring at my monitor and not doing anything to this Google page, well, nothing is happening. But as soon as I click on the input, on the search input box, then it will display to me my previous searches. Like, even before you have input anything, it will display to you like previous searches that you have done for easier user experience, which is really nice. Then I start inputting something. R, E, S, I'm searching for restaurants. And with each letter, Google Search Drive is sending requests to the server to see like, based on her previous search history, based on all other parameters, what on R she can be searching, RE. What can be she searching for RE? And you can see that the autocomplete on Google search will be constantly updating with every letter that you sign, and it will even help you like, maybe it's restaurants when you have input rest, for example. So it's actively listening to my inputs. What is it listening to? It's listening to me clicking on the input. So I clicked on it, and then it's listening to my keyboard inputs. I'm inputting some letters. So as soon as this event happens, we are handling the event. Handling the effect means running all the logic that we have wrote beforehand. So we are listening for click event when she clicks, and she clicks specifically on this user interface, on this search input, then we will display her previous searches. She started typing, and she's typing while this input is in the focus. Let's display some suggestions based on the letters she's typing. And the end, which is very common in like standard programming, like where you have a start in the program and the end in the program. When we're talking about web applications, there is like usually no end inside. Like Google will be listening for my events, for my user input, for as long as I'm on the Google site. Like it will stop only after I switch the tab in my browser, or I close this tab altogether. As long as I'm on the website, it is actively listening for my user input, like it's ready to react. Okay, let's talk about events in more detail. So an event is a signal that something has happened inside the application, and we need to react on this input. So as a user, I have lots and lots of things that I can do while I'm using the web application or I'm viewing a page in the browser. Like I can use a keyboard, I can use a pointer on my mouse, I can focus the input field, I can click on something. Also, for example, right now I'm giving this lecture from my laptop. So here I do not even have a mouse, so it's not a click event. I have a trackpad. So if I'm using the trackpad, it's not a click event, it's a touch event, and there are lots of them. Like you can touch the trackpad with one finger, with two fingers, you can do a swipe gesture, you can use three fingers in different directions. And these are all different events which can be listened to. And for example, like on Safari browser, you even support like Apple products support four fingers gestures. So like with them, you can scroll differently and so on and so forth. Lots and lots of events. And also, apart from using my keyboard and my mouse, we can also be viewing the history of my browser. We can be sending network requests, or there can be a socket connection. Socket connection is when the request, instead of request, we have an open channel. Like, for example, when we are typing in chat in Microsoft Teams, there is a socket connection. So instead of actively asking the server, like, has Yana typed something now? Has she typed something last second? Again, last second, like if I start typing something, all of you will see like these dots, like Yana is typing something. And as soon as I type something, you will all see it immediately. This means that instead of this chat being handled by like request, like asking, has Yana typed anything? We have a socket connection. A socket means that connection is uninterrupted. As soon as we have all joined this call, we have an uninterrupted video connection, but as long as you are using Microsoft Teams, all of your chats are WebSockets. So this connection is handled, and when something is happening, you receive the answer immediately. Instead of sending requests and getting requests, there is a non-interrupted connection, like an open channel, like a phone line, I suppose. So we can also be listening for user input in the socket. And this is mostly used in messages. Like, for example, when you are using like WhatsApp, when you're using Telegram, Viber, all of them are using socket connections. So when you're chatting with your friend, instead of like sending your messages as requests, get post, there is an open channel, which is kept open by the socket. And when you have closed the chat with your friend, this socket connection is severed just so that it does not use your traffic data and cumber your system. But as soon as your friend has written you something, then you get like a request from the server. Hey, something happened. Your friend has written to you in the chat, which is not opened. And then you open the chat and the socket connection is established, and then you can swiftly exchange the messages. Actually, like the invention of sockets is what allowed us to invent all these amazing messenger apps. They were not possible before without socket connection. And now we have Telegram, Microsoft Teams, Viber, WhatsApp, and whatnot, which is amazing. Okay, let's return back to our slides and see how we can listen for them. Every and each event name starts with on. So we are listening for something, for example, on click, on key down. Key down is when I'm pressing the button. Like when I'm pressing the button, there are two steps. I am pressing the button down on the keyboard, and then I'm releasing my finger and the button goes back up. So we have on key down and key up. So you can even pinpoint like is your event firing when I have pushed the button down or when I have released it. And also we can listen for the right mouse click, left mouse click, trackpad, and it all starts with on. So, for example, the snippet that is displayed on this slide, it will return you the all available events in your browser, and boy, there's a lot of them. So if we run this function get events, we can see that there is also more than 100 methods. So we can see that we can be listening for audio, for example, on waiting for key, on abort, on blur. If we are looking for event source, on open, on message, there is on focus, on blur. So for example, when I'm using a form, when I focus an input, like I have clicked inside it or I have used tab on my keyboard and now the element is highlighted, it's active, then it's focus. And when it's focused, for example, on focus user event, you can actively like change CSS styles, or you can display something, or you can do anything you want because you have listened for this event. And when I leave the input, for example, this form has several inputs like name, surname, age, etc. So I have input my name, Jana, and then I clicked out of this input to input my surname in the next one. So now on surname input, we have on focus event fired, and on name input, we have on blur, because the first one has lost focus and the second one has gained it. And for example, on blur event, I can trigger like validation of this input field. For example, this is a name. So edit a logic that this field does not accept anything but letters. Like I cannot input 11111 in this name. And as soon as this field lost focus, I can trigger my validation logic and, for example, append a new element to DOM with error message displaying like, sorry, please input only letters in the name field. And the user will immediately know that, hey, in order to correctly fill out this form, they will need to go back, then fill out the form correctly. Okay, there are lots and lots of events. So let's get to practice. Event handlers. So first we listen to an event, and then we need to do something. Like that's the main reason we're listening to them. So event handler is a function which can be assigned to the relevant property on an HTML element. Like we can see, for example, on the right of the slide, body, on click, equals, and in this equals, we can write something. And it shall be noted that with vanilla JavaScript, we are not doing it like so, but with React, when you study it, you will learn that that's how we are doing things in React. We are doing it differently. So if you remember this chart from the first part of this lecture, So we are primarily focusing on browsers and host environment. So there are events not only on browser side. We know that JavaScript can be run in different environments. Like for example, it can be run in the browser, but it can also be run on the server. It can be run in the Node environment. But Node events, they're very different, and we will not be covering them in this lecture. We will focus like on web applications, development for the browser. So the document object itself is an event target. It's what we are manipulating. It's where our events are happening. So when you were studying JavaScript, you have learned about JavaScript as a single-threaded language. JavaScript is able to handle only one operation at a time. It's single-threaded. Like, for example, when you have a function and inside of it another function and inside of it like third function, what happens is JavaScript as not compiled but interpreted language, so it's being run on the fly. And when JavaScript interpreter reaches out this code, so it goes on the execution stack. So first I go from the global context in this execution stack. I look into the first function. I see that there is a nested function. I put it above it on the execution stack. Then I put above it the third function that I nested inside. And then I see, there is nothing inside. This is the last one. And then synchronously, one by one, I start executing the innermost function, then the middle function, and then my parent function. And then the call stack is empty, and the JavaScript interpreter can go down line by line in my JavaScript file, find something else, find other nested functions, put them on the execution stack, and then execute them. But obviously, executing only one event at a time can be not very interactive. Like, for example, what if a user does several things? Or, for example, what if I'm still loading the picture, but the user already clicked on something else, but I'm still loading the picture, so I will not do anything, like the site is frozen. I suppose it happened to you several times when you are traversing the web and the site just stops responding to your actions. That's very frustrating. So in order to handle the document object model events, like all user input, we are using event loop. So you have studied that even though JavaScript is a single thread synchronous language, we are using the web API. We're using the browser itself, not JavaScript, but browser. And we are running a synchronous event in an entirely different data structure. So all synchronous code gets put on this execution stack, and all asynchronous code gets executed in the queue, in the event queue. And I suppose you have started there, for example, set timeouts, set intervals, promises, and all that. So synchronous code, asynchronous code. Everything that we are doing with the DOM is asynchronous because nothing of it can be done like snap, and we are actively waiting for user input. All DOM manipulations are asynchronous. So they are getting put in the queue, not on execution stack, but on the queue. And they are handled by web browser capabilities. So this gives us a delay. This delay obviously is not in minutes, but even in milliseconds, lots of things could have happened with our application. For example, we have, as Satanas, snapped our fingers and we have dispatched an event, like we are a user, we have clicked on a button. Program is running synchronously, and in the meantime, we put this event on the queue and then we handle it. But by the time the queue has run and we have executed the logic for this event handler, something might have happened in our application. Like, for example, the DOM node for which I wanted to change the styles was deleted by another event handler previously. So let us look at a classic example. So form, we have already discussed form today. Here we have a very simple form, an input field and a button to submit it. So what we are expecting by default. So when we click on the submit button, the onSubmit event should fire. It should not necessarily submit the event. we can do prevent default. Let's move to the right corner of our slide and look at the example. So first, the syntaxes we are already familiar with. We are getting the document body in HTML. We see that it's a form with an ID form. Inside of it, we have an input. It has an ID. It's type text. We are displaying it as a block. And even inside of this element, we have a button. Button, and its type is submit. And in it, we have the text snap. Okay, then we are getting this element document, get element by ID form, and then we are adding an event handler on submit. Remember that all events start with on. On submit, it's a function which will just put a snap text in the console, and by default, all buttons with type submit are reloading the page as a whole. This is like a relic from the days of multiple page applications and only server-side rendering. So we can prevent default behavior, and you will be using event prevent default a lot in your web development work. So please remember this method. It's very useful. It allows you to prevent any default browser behavior and add only your own custom logic which you would like. In this case, I do not want my page to be reloaded. I only want to this text be logged to the console. So console log snap event prevent default. Okay. Then I will be adding another event. So what will happen if we are adding several events? We have previously talked about on focus and on blur. So let's add an on blur event for the same input. This is a different function. It's called validate form. And let's see what we are doing there. First, we are getting the form, document get element by ID form. Next, we are creating an element. We have already learned how to do that. So validation message equals to document create element, and it will be a div tag. Then we are setting attributes like some styles. It will have a color. It will have like some height. And then we are setting an inner text. So we want this to be a div element with some text. And then we are saying, hey, please insert this element, the created element, insert before. First argument, what we are inserting, and second, where. So we are inserting this inside the form. Okay, let's see what will happen. We have input something in the input field, and then we click the button. We can see that the validation message has displayed, like, give me a scotch, I'm starving, everything that we have prepared. But if we look at the console, we can see that no snap text is displayed, like the on submit event has not fired. Let's analyze together what has happened. So on submit event did not fire. What happened? It shall be noted that we are actually doing two separate actions. We are not only clicking on the submit button. Before that, the input is losing focus. So in order to click on the button, I have to first click out of the input. Yes, so I'm clicking out of input and clicking on the button, and on blue event is being triggered first. So the on blue effect gets triggered. We are running our logic, the validate form function. We are showing a validation message, but this message, it pushes down the button. So when we click, the button is actually not there anymore because we have put it down with our validation message. So there is actually no click and there is no on submit event. So what happened? We are doing one click, but all document object model events are asynchronous. So they are all put on the queue. So I'm clicking, and first event that is happening is that my input loses its focus. It's on blur event being triggered, and then I'm adding another node in the document object model, this give me a scotch text. So then after this event has been run, the next event in the queue, the on click event is ready to be done. But by now, the click is not registered on the button because instead of the button at the same place, we have the text, the give me a Scotch text. Because like the place in the browser on where we have clicked, now we are not registering it as the click on the button. We are registering it just like a click on the text, because the button itself has been pushed lower by the results of the previous function. So you should be mindful of what will be there, what will be the state of your web application when this event is fired. So let's analyze this. We have the onClick attribute, and we can set it as a property, and therefore we can overwrite it. So it can be very useful when you are developing things to be overwriting your events. So for example, first it was onClick snap, but you can totally call it again, document.body.onClick equals another function, and then it's another snap. And if we delete our previous onBlur function and click our button, then we will console log another snap. Next, when we are using the onClick property, it will not be synchronized with the onClick attributes. It's not obvious, but there can be like a bit unforeseen circumstances. So let's see. Document body. In this example, it's an empty body tag. Then we are adding an onClick event. Document.body.onClick equals a function which will console log snap. And then we are setting document.body.id, which is equal to Thanos. Okay. Then we are actually clicking, and we have the snap displayed. And then after that, the ID Thanos will be displayed. So these events, because they are synchronous, they are not triggered at the same time. First on click, then adding the ID. Okay, next, the event object parameter. Our event receives an event object as a parameter. So browser needs to know what I have done, like what has happened. Where did my click happen? How did it happen? What did I press? What did I do? So let's see. Document body on click equals function. And in this case, we are just logging the whole event object to the console so that we can expect it. So here we have a mouse event. We can see that there is a position, for example, the client X and client Y. It means the position on the monitor. Like this click was registered, as we know from school program, like horizontal line, vertical line. So here we can pinpoint where exactly on the screen this event happened. And there are lots and lots and lots of other settings that can be viewed on an event. And it's very useful when you are trying to listen for a very specific event or manipulate it. So the browsers, they provide us several event interfaces available through object. So these events are browser dependent. So some browsers support different events. For example, Safari supporting the 4-finger gestures. Some are not supporting them. Here are lots and lots of events, so we can fetch event, we can focus on event, we can track it, there's time events, storage events, lots and lots and lots. And also, if you are curious, here's a snippet attached, and you can run it in various browsers and compare the results that the event interfaces will be a bit different. So instead of just using onClick, onBlur, onFocus, and all of that, we can use, as we in case we need it, the ultimate function at event listener. It's a bit similar to get by query, get by select query that we have studied before. So instead of just getting element by ID or getting it by tag, you can just write your custom query. Add event listener is very similar like that. So with this method, multiple handlers can be registered. So what is the syntax? It's a bit different. So document.body.event listener, and instead on click, we are just writing click, and we are writing it as a string, so we are adding parentheses. And as a second argument, add event listener accepts a handler, a function that will be run on the click event. In this example, it's just again the console log snap. And we can also override these functions. And we can add other listeners. So previously, when we were using onClick, we overwrote the event. So we had the snap, we overwrote it, and then it was just another snap logged to the console. But here, with document body add event listener, we can add more and more and more event listeners, and they will not be auto-written. So here, first we added snap, and then Iron Man hold my beer. And after we click it, both events are being fired. So we can also remove event listeners. If we want to, we can, for example, add event listener Iron Man snap handler and remove event listener for Thanos. And then after we click, only hold my beer will be displayed. So it's very similar to what we have been discussing previously with the DOM interaction. Prevent default, which we have discussed a bit previously. So, for example, when we are using a checkbox in our browser, what is the default behavior? When it is checked, then the attribute checked is changed on the checkbox. It's either checked or not checked. And if it's checked, then some styles will be applied and we will see the check mark inside of it. But if we want to, we can prevent it. For example, here we are getting our input by document, query selector, ID checkbox. We are adding event listener for click event, and then we're adding a handler. We are preventing the default, and we are outputting a console log. And after we have clicked it, we can see that the checkbox did not check. It stayed the same. Its checked status did not change. There were no styles applied, but a custom event that we have added, the console log, it has successfully been fired. And then I suppose two last topics for this lecture, events bubbling and events delegation. So as we have studied in this lecture, document object model is a tree. It's an hierarchy tree, and first we have like body, then we have header, then we have some other elements, and inside of them other elements. So what is happening if deeply, deeply, deeply nested inside of this tree, I'm clicking on a button? First, like my event, my click, it shall go through all these layers. So when I'm clicking, even though like from my user's perspective, obviously I don't see this document object model. For me, it's like all plain. It's a page on the web. But my event, it's being registered at each stage. So when I'm clicking, first it's being registered on the HTML level, on the body level, on the paragraph level, on the article level, navigation, link, and here is my button. So first my event is going down, and then it's bubbling up. So the reaction for my event, it's then going back up again from my button to the body throughout all these tags in the middle. So if event handlers were registered for the same event for both the parent and child, then both handlers will be run. First the child, then the parent. So I'm clicking. First my event is reaching the button, but nothing is happening yet. It's just being registered. Then it's propagating. So if we look at the DOM object model as with the tree, as we discussed before, so here's like the trunk of a tree, and here are all the branches going down. Maybe it will be even more describable as the roots of the tree. So first we are going down, and then we are bubbling, propagating. The bubbles are going up. And after we are going up from our button throughout the navigation, articles, paragraphs, and up until the body, on this stage, on this bubbling stage, all the events are being fired. So first the child event will be run, but then the parent. Sometimes this behavior is not what we desire. There can be custom logic, and we want for my click event to first be handled by the parent and then by the child. For example, I want my click to be first run on the body, the click handler to be run on the body, and only then on the button. So the second phase is called bubbling, the event is going up. The first one, the diving phase, is called officially capturing. So we can add the specific use capture parameter to add event listener. So we can see in this example document, get elements by tag name, then we are adding event listener on click, then we are adding as a second argument the handler, and then there is a third optional argument. And we can use this use capture parameter, and if we set it to true, by default it's false. If we set it to true, then our event handler will be fired during the capturing phase, going down, not going up on bubbling. So if we look at the scheme, there are three different event phases defined in the web development standard. First, there is the capture phase. The event propagates through the target ancestors from the window to the parent target, like we are going from window, from document to all our layers till we hit our button, the lowest layer on which we have the event handler. Next, we have the target phase. So the event object arrives at the event object's target, and this is the stage where we indicate that the event doesn't bubble. So if we have this third argument sent to true, this is where everything will fire. And then the bubble phase, the event object propagates back from the target addresses from our button through all the layers till the document and window. So this is the bubbling phase. So with different colors we can see on the scheme on the right. First is the capture phase. We are going down with red arrows. Then we are hitting this element, its target phase. And then from the target phase, we are going back up with the bubbling phase. And the very last thing for today, the event delegation. Because events can be propagated to the parent, then we can have the event handler exclusively on the parent. This can be very useful when you have several similar elements. For example, when you have a list, or when you have, for example, a Google map with lots of points to click. So instead of adding event handler for any point, you can just delegate this event. So let's see this example. First, we are getting the document body in HTML. Next, we are adding creating the handler. Parent click handler is a function, and it's accepting an object as its arguments, and then it will log all of this to the console. Next, we are adding event listener. So on click, there will be a parent click handler targeted. So if we look at our body, we can see that there is body. Inside of it is a div with an ID and with our style that we have seen previously. And after we click, we can see that there is a target on our event. We have a target property. And there we can, using this target property, delegate our event to all its children. We will study this topic of event delegation in more detail during next lecture. This was just a preview. So there's only one slide for event delegation. And this is a bit more difficult topic. So after you have had a bit of time to understand everything, to relax after this lecture, on the next one, we will be talking specifically about browser object model, how browsers are handling our events specifically, and talk more about event delegation in detail. And with that, I would like to thank you all for staying with me for these 2 hours. It was my first lecture for you, and I'm very happy to be here, and I'm hoping that you enjoyed the lecture. And with that, I'm wishing you a very happy Friday and amazing weekend.
Yeah, thank you a lot.
Yeah,
Thank
thank
you
you.
too. Thank you. Bye.
Bye. Have a nice weekend.